So again, there are two interpretations we have for derivative. One is the slope of the tangent line to the function. The other one is on the board, rate of change. All right, we have an illustrative example on the board given the dimensions in terms of b. B is of course any arbitrary or any value. And since we are looking for the relationship between the rate of change of volume with respect to B, we need to name our volume. And obviously, the best name would be V, no? Capital V. And with that, therefore, we are looking for the derivative of V with respect to B, meaning the rate of change of volume with respect to B. All right? So how are you going to start? In the first interpretation of derivative, which is slope, most of the time the function is given. But with regards to rate of change, this is going to be somehow challenging because you will be the one to formulate the function. Through your knowledge of formulas, most of the time we'll be talking about volume, surface area, triangles, and the likes. No? Those whose relationship can be determined from a particular drawing, solids, plane figures, and so on and so forth. For the volume of box, I guess you knew that it's going to be the product of the three dimensions. We don't know there which dimension is the length, the width, and of course the height. But then eventually you may do the product in any sequence naman. All right. All right. I guess it's going to be somehow difficult to evaluate its derivative in this particular condition. But you know probably through algebra that you may do away with those grouping symbols by multiplying these factors. And thus we will come up with a function in polynomial form, a third degree function of b. All right, the first step and the second step in determining the derivative using the 5-step process. Next, and then little by little, we need to do away with grouping symbols because this is the so-called appropriate method of applying step number 3. And of course, we need also to substitute the value of b. Just take note later on, all of these terms must be eliminated by its counterpart in this part of the entire relation. Okay, I suppose you're still familiar with that diagram on the board taken from the Pascal's triangle. So we will take note of these coefficients 1, 3, 3, 1. Now I have written there the initial steps. Let's consider first the first term. The exponent will be decreasing, meaning starting from 3, then 2, then 1, then 0. There you are. And for delta b, which is the second term, it's going to be in ascending order. All right, that's it. So the first term, exponent is descending. Second term, exponent is ascending. Simplifying further, that will be our expansion of b plus delta b all raised to 3. Okay, after substituting and removing all grouping symbols, to this, we have to substitute this expansion and remove this parenthesis, taking into consideration that the sign outside is negative. So that means the signs, these were the expressions below before. Now the sign of b raised to 3 is now negative. That of 5b squared is negative from positive 4b to negative 4b. And as I have said, take note of them. All of them must be eliminated. In other words, if you are not able to eliminate any one of them, then something is wrong with your entire solution. You need to go back. So how will you know that step number 3 will end right here? Did we succeeded? Look at all the terms. All of them has delta B as a common factor. That means we succeeded. And dividing through with delta B, that is the start of step number 4. All right, that's it. I have shortened the solution. And when you divide everything by delta B, then naturally that's going to be the result because you have canceled out delta B in each of the terms. Then applying the limits as we make delta B very, very small will become the derivative of V with respect to B. Applying limits of both sides in there, as delta B is made very, very small, will give us the derivative of B with respect to 0, and all those terms with delta B in them will become 0, leaving us with this as our final answer. So thank you very much for seeing this video. Hope to see you next time. Bye-bye.